Good morning, and uh, in these particular lectures, uh, we are going to review the basic structure of the tensor product Hilbert space and build up to entanglement, and then we are going to see the applications of entanglement to quantum limited metrology. Okay, starting with it, let's say this is basically a review. So suppose I have a ball that can be colored uh, red or blue. Now the state of the ball, or the quantum state of the ball, can be given by a vector which is a superposition of the blue state and the red state. So this would be the quantum mechanical description of the ball, where you can take color, for example. Color is a quantum degree of freedom. Now, what happens when I have two balls? The possible states for two balls are, both balls can be red, blue. The first one can be red and the second one can be blue. Or I can have the first one to be blue, second one to be red, and I can have both the balls to be blue. And in general, the quantum state for two balls, I'll represent it as a superposition of all these states. It's just your fundamental principle of counting. So this is to motivate the tensor product structure. A tensor product is used to express composite quantum systems. Two balls, or a charged particle and another charged particle, or even 2 degrees of freedom of the same particle, like the electron degree of freedom and the spin degree of freedom, and let's say the positional degree of freedom. So in general, if I have two vector spaces V and W, and I can have the orthonormal basis this is the orthonormal basis for V, and I'll have the orthonormal basis for W, basically the basis vectors. The tensor product space is another vector space which is spanned by the following bases. So basically, in general, I'll have these pairs which are serve as the basis for this vector space, V tensor W vector space, and by construction these are going to be the basis vectors for the tensor product vector space. So in other words, I call V this symbol, this is the symbol for tensor product, this is the tensor product vector space.